So our next presenter is Abdullah. Abdullah, are you ready?
Yes, I am. And let me just share my screen. Can you see the screen here at the website? Lovely. Well, hello everyone. My name is Abdullah. I'm a PhD student, and I am the third year of my PhD student, and I'm going to present something a bit practical. I didn't really prepare any slides at the moment, so we're gonna go with Google Colab that mostly everyone uses, and I think the presenters who came before me already explained the Jupyter Notebooks and also the Google Colab. So my talk is on the Quran verse similarity classification task using Arabic pre-trained models. So we have a data set that has a similarity score, and we are trying to do a classification task. The good thing about these data sets that we have at the moment is already annotated and already labeled. So right now we are in the Google Colab. Going to give you what I have done in the past year. So let's go. For the configuration, I already executed most of the code in here. So we need to install transformers, install Farasa Pi, install the PyArabic, and also get the pre-trained model. The pre-trained model that I used is from Camel Lab. It's called CamelBird. So I already installed it and also import the important libraries that I'm going to use for this experiment. And also instantiate the tokenizer also from Camel Lab. What is interesting about the CamelBird has already exclusive, let's say, type of Arabic, which is classical Arabic. That's what I'm going to use for this experiment. And now I'm going to go for the pre-processing. So I already loaded the data set. We have four, let's say, 4 columns. We have the ID, verse 1, verse 2, and the label. And we need the label that is label 2 and label -1. So the dataset has 4 labels, which is 1, 2, -1, and 0. And for the purpose of my study, I only need 2 and -1. So what I have done is just remove all the records that have label 1 and label 0. And then just to make sure that I get that right with the coding. And then after that, I need to convert the label into 0 and 1. So number 2 can take number 1, and -1 can take number 0. It's really important to have 0 and 1, and then you can go on from there, 2, 3, and 4, because if you have -1 and 2, and if you load it into the model, it will cause problems. So it has to be starting from 0. So I did that with this cell over here, and just to make sure we also see how many values that we have. And then after that, I need to set the verses to be a string. And then after that, I split it I split the data set into train, validation, and testing. So after I've done all that, we have looked at the data frame for the testing. We can see the index in here is random, and we need to reset it. The reason is because it will cause problems later on in the model. After we reset the index in here, we can go to the tokenization process. It's really important to do the tokenization process if you want to feed it into the model. So we tokenize the training set, the validation set, and the test set. After that, we can have a look at the tokenization part in here, and we can see the input IDs, the token type IDs, and the attention mask. These are all important for the BERT models. I just wanted to show you that these tokens are really important. All right. So after that, we need to do the data loader. The data loader is also important step before you feed it into the model. So you also assign a batch size, and also you do the data loader for the training, and you also do it for the validation, and you also do it for the testing as well. And for the testing, you don't need to include the label so that you can actually test the model. And then we can later on evaluate the model. So in the model section, we can see here that we load the Camel BERT, and we load it into the CODA, which is the NVIDIA graphics card. As you can see there, in the output cell in here, we have 12 layers of BERT. And then after that, we set the optimizer and learning rate and the epochs and all that. And then you go into the training. So the training simply goes into batches, and then it unlocks the training batch, put it in the CODA, and going through all the layers of BERT. And then it goes to another batch and so on, and also for a number of epochs that you assign to. And we can see the end results in here. We can see the number of epochs that you have done, and you can also analyze the training loss, the validation, let's say accuracy, and all that, so that you can make your own analysis later on in the experiment. After that, we do the testing for the test set, and also you could later on save the files as well. So after we've done the training, validation, and testing, now we can get into the reporting. So in the report section in here, I have the classification report, the confusion matrix, and also coefficient correlation calculation. So in here, you can see let's say the classification report and the accuracy as well. So I got really good accuracy results in here for the test set. Also, you can do the confusion matrix. There's a nice figure to that. And then later on, I did the coefficient correlation, and also Pearson as well. And yeah, this is really the experiment that I have done for the Pearson data set using Camel BERT model for the pre-train. So yeah, this is my presentation. Hopefully, I made somehow meaningful to everyone in here. Thank you.
Good work, Abdullah. Thank you very much for that. And you finished just on time. Excellent. Thank you very much.
Thank you. Great.
Does anyone have any questions for Abdullah?
Abdullah, what did you have to, presume you had to set up accounts to use this stuff? Do you have
For the Google Colab?
Yeah.
Yeah, I believe you do. You need to have a Google account, such as Gmail or Drive. So in the same for the same account, you could just Google Colab, and you can use your Gmail account and run your code in there, and it's free as well.
It sounds as if the consensus is that everybody should be using Colab rather than notebooks on your own laptop. Is that right?
It is important because our own laptops don't have really, let's say, NVIDIA graphics cards. If you only use the CPU, that means all the experiments will be, taking days. So that's why we use Google Colab, because they have really good NVIDIA graphics card that they can actually speed up the process of experimenting with training, validation, and testing as well.
And it's free.
Yeah.
Yeah. It's all free. Yeah. Are there any constraints on using it in Saudi Arabia, for example?
No, there are no, that's one of the good things. There are no constraints at all. However, there are constraints in terms of the hard drive and also the RAM, the memory. So you couldn't really use a bigger model. If you use a bigger model, that means you have to reduce the batch size and all that. But there are ways to figure that one out. But yeah, there are constraints when using free Google Colab.
Okay, thank you.
Thank you very much.
Thank you, Abdullah. Thank you for that. Thanks.
Thank you.